Hello everyone. Today I'm going to explain architecture of 8051 microcontroller. 8051 is an 8-bit microcontroller, which means its data bus is of 8-bit size. So when data bus is 8-bit size, arithmetic logical unit is also 8-bit in size, which performs operation on data. So I can perform only 8-bit arithmetic logical operation at a time. All registers are 8-bit in size. All SFRs, special function registers, are 8-bit in size. All ports are 8-bit in size. So 8-bit microcontroller has 8-bit data bus. That is the reason why we can perform only 8-bit operation at a time. It has 4 kilobytes of inbuilt ROM memory. ROM is permanent memory. So it has 4 kilobyte of inbuilt permanent memory for storage of program. Program memory is of permanent memory nature. So when my program is 4 kilobytes up to 4 kilobyte, I can store my program in its internal program memory. And when it exceeds the 4 kilobytes, I can store my program in external program memory. 8051 microcontroller has 16-bit address bus, which means 2 raised to 16 is 64 kilobytes of program memory can be interfaced externally. So I can interface 64 kilobytes of external program memory through which I can read program. I can also interface 64 kilobytes of data memory. Both RAM and ROM are overlapping their addresses. Address range is same for both the memory location, but control signals are different. PSN bar program set enable signal is used to fetch instruction from program memory, and read bar is a signal which is used to read data from data memory. So control signals are different. That is why at a time two memory locations are not accessed. Only address will select the location, but read operation will be carried on memory whose control signal is generated. So it has 128 bytes of internal RAM memory also. When my temporary data, which is coming out of arithmetic and logical operation, is of 128 bytes. If my temporary data is up to 128 bytes, internal RAM memory is sufficient. If it is more than that, then in that case, external RAM memory is used. So as I already explained, external RAM memory is interfaced through external address data bus, and read bar, write bar are the control signals which are used for read and write operation on external data memory. It has four programmable 8-bit ports. It has four ports through which we perform read operation or write operation. So it has four 8-bit ports, which means I can perform 32 bits input output operation. And these are programmable. What does mean by programmable? Programmable means I can configure either these port lines as input lines where I can read input data, or they can be configured as write operation where I can transfer my data to external world. So these four 8-bit ports are programmable. You can configure them either as input port or output port. It has two 16-bit timers. 16-bit means 2 raised to 16 is 65,535. So my timer can count 65,535 clocks maximum. After that it will roll over and roll back to 0. This is called overflow condition, timer overflow condition. So maximum 65,535 clocks can be counted by these two timers. There are two timers. T0 is used to indicate timer 0, T1 is used to indicate timer 1. And they can be used either as time delay generator or counter. What is time delay generator? Delay operation. When my timer receives clock through oscillator, timer is used as time delay generator. Because oscillator generates continuous clock pulses. Clock pulses arrive at regular interval of time. When I say my oscillator is of 1 hertz, which means it generates 1 clock per second. So when timer counts 1000 clocks, I can say that 1000 seconds have passed. So when your source is continuous clock pulse, your timer is used as time delay generator. And when the source of clock is external circuit which is converting an event into clock pulse. What is this event? Suppose bottles are filled. Bottles are filled. I want to count how many bottles have filled. So here every bottle converts into 1 clock pulses. So number of bottles are represented by number of clock pulses. So here number of bottles filled is not regular with respect to time. Plant may have demand, so number of bottles are more. Plants have less demand, number of bottles are less. Plant shutdown time is there. So here number of clock pulses is not regular. It is irregular with respect to time. So here number of count represents the number of events. So in such cases, timer is called as counter. And these clocks are applied through T0 and T1 pin of microcontroller. When you apply clock to T0 pin, timer 0 receives clock pulses. When you apply clock pulses to T1 pin, timer 1 receives clock. So T0 and T1 pins are used as clock source when the timer is used as a counter. It has 5 interrupts. Interrupts are very interesting topic. Whenever microcontroller receives an interrupt, it suspends its current operation, jumps to subroutine, executes the subroutine, gives service to the requested interrupt, and then return back to the same place. So there are 5 interrupts, 2 are external interrupts and 3 are internal interrupts. 2 external interrupts are INT 0 pin, INT 1 pin. So when you apply a trigger pulse on INT 0 bar, external hardware interrupt 0 is generated. And when you apply a trigger pulse on INT 1 bar pin, external hardware interrupt 1 is activated. And three internal interrupts are timer 0 overflow flag. When TF0 flag is set, internal interrupt is generated. Timer TF1, when timer 1 will overflow, TF1 flag will set and interrupt will be generated. And last is serial communication. When I receive my data serially, RI flag is set. When I transmit data serially, TI flag is set. So these are 3 internal interrupts. They are also called as software interrupts. So these are 3 internal interrupts, and INT 0 bar, INT 1 bar are 2 external interrupts. So there are total 5 interrupts. Whenever an interrupt is generated, microcontroller stops its current execution, gives service to the requested interrupt, returns back to the same place. So it has 5 interrupts. It has one single UART for serial communication. UART stands for Universal Asynchronous Receiver Transmitter. So through this peripheral, microcontroller performs serial transmission and reception. It has one SBUF register, serial buffer register, through which it performs serial write operation or read operation. When we write 8-bit data in SBUF register, UART starts transmitting this 8-bit data serially bit by bit through TXD pin. So serial transmission is data is transferred through one conductor bit by bit. In parallel, all 8-bit data is transferred at one instant of time through 8 conductors. But in serial, you have only one conductor through which you have to transmit 8-bit data, so data is transmitted bit by bit. It has RxD pin for serial reception, through which it receives data. So it receives data bit by bit serially. It receives data bit by bit serially and stores the 8-bit received data in Rx in SBUF register. So microcontroller 8051 has Microcontroller 8051 has one UART which is having one SBUF register, so we can perform either write operation or read operation at a time. When I am carrying out write operation, I cannot carry out read operation, and when I carry out read operation, I cannot perform write operation. Therefore, I can say that 8051 is half duplex serial communication system. Next is power control modes. 8051 has two power control modes. What is this power control mode? Sometimes microcontroller do not perform any operation. So in this case, when it is not performing any operation, we must bring our microcontroller to sleep mode. When we bring it into sleep mode, power supply is there, but clock is disconnected. When clock is disconnected, microcontroller stop fetching of instruction, execution of instruction is stopped. So this cutting of clock supply to microprocessor moves into sleep mode and it saves power because microcontroller is used in embedded application and embedded application generally runs through battery, so battery has reserve power, limited power, so we don't want to waste power. To increase the life of the battery, power control modes are used. There are two modes, power down mode and idle mode. In both these mode, either you enter into power down mode or idle mode, microcontroller stops fetching of instruction, execution of instruction. However, in case of idle mode, all peripherals are running. Timers are running, serial communication is running. So whenever timer will overflow, microcontroller will wake up and give service to timer. Whenever in case of serial communication we receive data serially, RI flag is set, microcontrollers will wake up and will give service to serial communication. And in case of power down mode, all peripherals are also brought into sleep mode. Clock is completely disconnected. No serial port, no timers are running. In this case, only external hardware is the source through which microcontrollers wake up. When there is external trigger, microcontrollers will wake up and will give service and then again move to power down mode. So power control modes are used to save battery life. To increase the battery life, we use power down mode and idle mode. This, let us give an example of this remote control of air conditioner. So we use remote control for small time. We will use it either to set the temperature, turn on or off the air conditioner. For most of the time, it is not in use. So when it is not in use, that time we bring it into sleep mode. And when we press any button, this every button generates one external interrupt and it wakes up and gives service and then again returns to power sleep mode when it is not in used. So this is how we increase the life of the battery because every remote control runs through battery. So we want battery to last for a longer time to save money. So this is how power control modes increases the life of the battery. It is a Boolean processor. It can perform bit operation. It can set a bit, it can reset a bit, it can transfer a bit from one place to another place. So it is a Boolean processor. Out of 128 bytes of RAM location, 16 bytes of RAM location are used for bit operation. So 220H to 2FH, this is the 16 location of RAM location which is bit addressable. So I can set or reset any bit of this 16 RAM location. And last point is again the same point. It is having 16-bit address bus so that you can interface 2 raised to 16, 64 kilobytes of program memory as well as data memory. It has three control signal, one for program memory, PSN bar, two for data memory, a read bar and write bar. This is the block diagram of 8051 microcontroller. It has on-chip timer counter, on-chip interrupt controller, on-chip power control unit, on-chip UART, on-chip ports, on-chip RAM, on-chip ROM. So also CPU is connected to all these peripherals on chip. So this is ready to use computer. Microcontroller is ready to use computer. When I want to develop any embedded application, I have these basic requirements on chip. So one chip contains all the basic requirements. So I do not need to interface any peripheral to my microprocessor. So processor is internally interfaced to all these peripherals and it is ready to use computer. This saves the space and price also. So embedded application requires limited space and price also. It has a space and price constraint. So that is why microcontrollers are developed. It is developed keeping in mind the embedded requirement. So microcontroller can be defined as it is a programmable device which consists of microprocessor, program memory, data memory, ports, timers, UART and other peripherals on a single silicon chip. It is used in embedded application where device is used for dedicated operation. This is most important thing. In embedded application, device is used for dedicated operation and space and price is constant. Embedded applications are such as washing machine. So washing machine has microcontroller. It has microprocessor which can perform many operations, but their operations are defined. There are buttons, there are indicators to indicate the operation. So it can perform only those limited operation. That is why it is called as embedded application because microprocessor performs only dedicated operation. Remote controls. Even in today's air conditioner, we have electronic card which is used to control the air conditioner. So these are again limited operation, even though it is has some processor, but that processor performs only limited operation. Display temperature, turn on and off air conditioner. So limited operations are there. That is why it is called as embedded application. So with this I conclude my today's lecture. I hope you liked the lecture. If you have liked the lecture, so please share with your friends also and subscribe my YouTube channel so that when I load next lecture, you will be intimated. Thank you. Thank you.